start our.
The law is that might always happen, and if you don't follow it, you'll go to jail.
Ah, I don't know about that.
I can't get the song "This Is How Many Ghostbusters" out of my head.
Oh my gosh. All right, so we brought candy from Europe. We bought it in Dublin. No, were we in Dublin when we bought this?
We were.
Where were we?
I believe we were in Dublin. Oh, did
Yeah.
you have a nice trip?
Yes, thank you. We had a great trip. If there's time, I want to show you some video that Jason took with a drone because it was amazing.
He has a drone.
He has a really nice drone. It was his birthday present to himself last year. It's the kind of thing that, like, I'm afraid of it. I won't mess with it because it's like super nice and it shoots video in 4K and it's incredible. So
it's really funny because the second to last day was my favorite there because we had an Airbnb.
Well, hang on. Wait a minute. Let me start this around, then you can keep talking. So pick one. These are kind of like Whoppers, sort of. And I don't know how to describe these. But anyway, take one and pass it around. Keep going, Drew.
I'm fine.
You don't want any? You've already had enough of them. No Maltesers even?
No, I've not had any.
Oh, okay.
But
anyway, keep going.
we were in the beach there wasn't regular sand beach. It was like these big boulders, and they're completely smooth because they've been what's the word?
Weathered by the yeah.
And what's a rock? Oh, sorry,
it's just a chocolate.
And big boulders. No, I was wondering what a rock is.
It's the best candy.
And it was really fun jumping across them, but Dad was too busy sucked into his drone. I was able to jump across the rock without getting out.
Yeah, it was really pretty. And Whoppers are like malted milk balls if you've never had them before. They're good. They're very good.
And this is just white chocolate.
Is that what it is? I was gonna say, I have no idea what it is. Yes, absolutely. Yeah, it just says white chocolate pieces. So, but they're Nestle, but they're
they look like holy bread.
I went to
communion wafers.
I went to a NASCAR race and had it.
Wait, you have to go.
Oh yeah.
And I pointed to I slapped my grandma. That's what this world has.
Yeah, it's true.
It's no longer a no-fly zone.
It's a no drone zone.
Smoky zone. It's a no drone.
Well, and apparently they're picky about drones over in Ireland and in the UK. So Jason had to be really careful about where he was flying. So he basically only got to fly it really twice, right? First at the place we stayed at in Scotland, and then second at the place we stayed at in Clahane near Liscannor, the last place.
Why could he only fly it twice, and what did
because they have all these rules about it over there.
Really?
Lots of rules. I don't know. Lots of
you cannot fly it.
rules.
You cannot fly it here.
Because Ireland is planning to take over the world.
Yeah. But what I thought was really interesting, and hopefully I'm gonna have time to show you guys this video, but what I thought was super, super interesting was the place we stayed at in Scotland was on this island called Isle of Mull. And it was a little farmhouse. It was a real live active farm with sheep everywhere and these massive deer, huge big red deer. He was yelling at us. The deer was yelling at us from the top of the hill, making weird deer noises. It was real. Oh yeah. But anyway, down at the beach, you could see where when you look, we talked earlier when we did earth science, we talked about, we talked about how the earth forms in layers like this, and they're horizontal layers, right? But the rocks at this particular beach, there was a mountain that was cut off like a cliff, and you could see the horizontal layers, and then there were all these other rocks that were up on their sides, like they had fallen off, and then they were standing up this way. So it was really neat.
I hypothesized about it that it was once like a big mountain, and then something like a meteor or it got weathered or something happened.
Yeah.
Got hit by a lightning bolt. I don't know. Anything hit it.
And then convergent. I don't know.
And then it
have to go back and look.
And then it fell down on its side and made two different mountains.
I did look up like just basic Isle of Mull geology, and apparently Isle of Mull is like a mecca for geologists. They love to go there because it has some very unique and very specific features, and they all love it. And there's caves and all this business. And excuse me, that's where that
geologist Great Wolf.
Yeah, that's where that what's it called? Fingal's Cave. Fingal's Cave. If you've never seen it, we didn't go. I would love to have gone. But it's the way that the rocks formed, their crystalline structure, they're like these giant hexagonal pillars, and the whole cave it's so neat. So anyway, all right, go ahead and open your Open your notes.
I know how the dinosaurs were extinct. I do.
Oh yeah? How so?
They were trying to swim to Europe to take over Europe, but they can't swim.
Yeah, there's
Not
that.
true. The Diplodocus.
Diplodocus. Did you all see, by the way? Wait a minute. Did you all see that there's a card over there from Miss Jackie, where you turned in your work? We're gonna make sure that we all sign it if you have Miss Jackie for Spanish. Her dog Tupelo Phil died in his sleep this weekend, so it was kind of a shock. He wasn't.
How did he die in the sleep?
I don't know. Maybe he had a heart attack or something. I don't think anybody really knows, but he wasn't sick or anything to my knowledge. So it was really a shock. So yeah.
What group is Saba in?
It's up there. I can't remember. I wrote them down up there. I have them on here somewhere, but we'll just roll through our notes first. All right. So everybody, get your notes out. You got your notes out? Okay. Tell me who these guys are at the top of your page. You got two little silhouettes of people. Do you know? Uh-huh. David Bowie.
Look like they want to
She's got David Bowie. Wait a minute. She's got. It is R.I.P. They're both deceased. Yeah. Who sings it? Who sings it? David Bowie and. Do you remember the band? Queen, right? Who's the singer of Queen?
I don't know.
Freddie Mercury. Freddie Mercury.
They look to me like they want to party.
Well, believe me, they partied enough. Oh, I love it.
We will rock you.
We're young.
We will rock you.
And cut. All right, so that was excellent. All right, so pressure. We're going to talk about pressure. I have a tiny little silly experiment to try that your book mentions. All right, so
I think we should start a band.
I got right here. Anybody know what this is?
Test you.
Nope. Nope. It's a flask. What kind of flask? Anybody know?
It's a glass flask.
It's an Erlenmeyer flask.
Erlenmeyer?
What's the guy's name?
Erlenmeyer?
All right, so
Who would name their child Erlenmeyer?
what do you do?
Great question.
I think that's his last name.
Who would
What
name their
do
last
you-
name Erlenmeyer?
We're all still wound up. So what will happen if I blow air into this balloon right now? Hypothesize what? What's gonna happen?
It's gonna
expand.
Expand, okay.
It's hot. If you
All right.
try too hard.
Yes, we agree? All right. What will happen if I put it inside this flask and now blow? Who has a hypothesis?
It's gonna
What's up?
Who
expand.
has one?
I'll fill the glass.
Okay, what do you?
It will fill up the glass too much, and if you keep blowing, it might break.
Okay, what do you think?
It's going to fill up the glass, and it will be the shape of the glass.
Okay, anybody else?
Might be a little harder because
Fill
it
up the
would be
glass.
harder to expand.
It'll be harder to expand. Why would it be harder to expand?
Because it's contained.
It's contained.
Also, it's kind of.
I'll fill up
It
the glass.
depends like how you hold it. You could close off the top.
Ah,
and
okay.
There will be no like air.
All right, well, let's give it a shot. So I've got it about an inch above the top.
Hold up.
What happened? Why isn't it going in?
Because there's no air.
Because you haven't blown in it hard.
Why blue? Why not sky?
Because there's air at the bottom of it.
Yeah, there's air in here, right? Where's that gonna go?
Nowhere.
Nowhere, right? It's got nowhere to go.
It's gonna go back up.
If I blew hard enough, this would probably break the balloon because it's not as strong as the glass. But if it were stronger than the glass,
It's a fly. It's okay.
yeah, I had the door open because it was hot, so now they're blowing glass.
Well,
All right, so
Spider in my dad's
we're gonna
car
do
today.
one more hypothesis. All right, now I have put a straw in here. Now what's gonna happen if I blow? I'm not gonna
Then
suck,
it
I'm
will-
gonna blow. What's gonna happen?
The
Oh, you have
air's
to
gonna
lift
go
the straw a
through
little
the
more
straw.
first.
You think I have to lift it up a little? What
Yeah,
do you,
because
what,
it's
anybody
stuck
over
in the
here?
bottom.
The balloon's gonna push the air through the straw.
Okay.
I
Yep.
agree.
All right, let me move it away from my eye so I don't put my eye out.
Yep.
Oh, look at
Wow, that looks so pretty.
this. That is kind of pretty,
That
huh?
is so pretty.
Fancy.
If you just
What?
no.
Oh boy, that's always fun. There we go. So
What?
what happened?
That sound was awesome.
What was the difference between the first and the second time?
So weird.
Okay, well,
There
the
was a-
first time it's
I mean, the second and third time. Sorry, the first time I was just in the room. Actually, what's the difference between all three? Jack, you have your hand up.
So the third time, the straw
Mm-hmm.
with the balloon was pushing all the air that was in the glass out the straw.
Right.
To let it have room to expand.
Perfect.
The second time, there was air in the flask, so
Mhm.
it just pushed the air up
Right?
where there wasn't air at the bottom of it.
Right. And what happened when I just blew it into the room?
I picked through.
It turned into a real regular balloon. It expanded.
Right. So what we're dealing with here,
Got moisturized.
so what we're dealing with here is air pressure in two areas. Air pressure inside the balloon and outside the balloon. The membrane being what separates them. What this wants is for the pressure both inside and outside to be equal. If inside and outside are equal, it's just going to sit here like this, right? But if I blow it up and then let it go, we saw what happened last time, right? Where'd it go? I think it went everywhere, all right? So that was because the pressure inside was greater than the pressure outside, and the outside pressure, you know, is the inside pressure is pushing, outside pressure is pushing everything at one time, and it comes flying out of there. I know, we'll watch some Mark Rober at some point. All right, so let's have a look at your notes. All right, so the word pressure is related to what word? Press. There you go. All right, good. It's related to press. It refers to something pushing on a surface. Pressure is equal to the force exerted on a surface divided by the total area of the surface. So if you look under there beneath old Dave and Fred, you got a little equation, right? Pressure equals force divided by area, or P equals F divided by A. All right, so what's the unit for pressure? What do we use? The unit, what is it, Drew?
1 PA equals 1 N
Right.
slash
A Newton meter squared, but what does the PA stand for, Jack?
Pascal.
Pascal, okay, yes. So this is
Medallion.
Pascal, and we abbreviate it with a capital P lowercase a. Y'all see that? All right, so a unit for pressure is the Pascal. 1 Pascal equals 1 Newton meter squared, 1 Newton over meter squared, right?
Good question.
Yeah.
Is when you blow up the balloon, it's not filled with oxygen, it's filled with carbon dioxide. Right?
It's filled with air from your lungs, which does contain more carbon dioxide than the air you inhaled, but there's still some oxygen in it and nitrogen and everything else.
But does that what is more dense, oxygen or hydrogen?
Hydrogen's very, very light. It's the lightest.
Well, what about what's it called? Carbon dioxide.
Carbon dioxide or oxygen?
Yeah.
I'm not sure.
Because
I think carbon dioxide is, yeah.
Wouldn't that mean
Yeah.
depending on?
Well, it's it's versus being a single element molecule, it's 2 elements. I am pretty sure that the carbon dioxide is a little heavier though, because I think it's.
But I mean, it would be able to fill up the balloon a little less before it pushes down.
Maybe, but it's probably super negligible. Super negligible. All right, so let's look at this
So, like,
this diagram.
Hard to tell.
Yeah, let's look at this diagram here with a fluid, okay? Now it says a fluid, that's your blank, right, is a substance that flows, there should be a comma right there and I missed one, assumes the shape of its container, or it should say and, actually, I think the word and is missing. I'm gonna put it right in there so I have it. Okay, and assumes the shape of its container. Hang on. Both liquids and gases assume the shape of their containers and are thus considered fluids. All right, so we look at those 3. All right, somebody.
Isn't that unless you have a teeny bit of gas inside of a big container, doesn't really assume the size of it because the gas is in the middle and the container's outside, so it doesn't really assume the size of it.
I'm not sure I understand the question.
Like if you're going to have a big massive container
Mm-hmm.
and then you put like a little teeny bit of smoke, which is gas in it, right?
Smoke's actually solids within a gas.
Well then,
The particles are solids.
Oxygen
Yeah.
inside that.
Uh-huh.
If you put only a teeny bit of oxygen inside, it's not assuming the size of its container because it's only a teeny bit.
Well, it would though, however, because if you put that oxygen in, what was in it to begin with? If it was a container that appeared empty, it's not really empty. It already had gas in it, unless it was a vacuum. So the only way to do that would be to take, like, for example, if we sucked every bit of air out of here and made it flat, and put only a teeny bit in, it's assuming the shape at the moment. And this is a flexible one, so it's a little different. Same thing though, if you, like a can, if you could, or a water bottle, you suck all the air or water out. You know, when anybody ever get a water bottle and if you suck the air out of it, it starts to collapse on itself, right? Mm-hmm. All right. So if you let's look at these models in this diagram because I think these are really good and helpful. So they've got 3 little, okay? So that first beaker has a solid in it, and it holds its shape. It has a fixed shape and a fixed volume. That's how you know what a solid is. Now you have to think about stuff like, all right, let's say sand. Okay, sand's a solid, right? But if you pour sand into a vase shaped like this, does it still maintain its shape? Think about it real hard. Think about it. It does, because the sand is the little grain of sand. What you're dealing with is lots of particles of a solid. And there's actually gas in between them or water in between them, whatever you put in there. So a solid is always going to maintain its shape and its volume, okay? And a liquid will take the shape of its container and it will have a fixed volume. So that means that if I take this amount of water, no matter what container I pour it in, it's going to take the shape of this turvis, or if I pour it in a little curvy vase, it's going to take the shape of the vase, but the volume is not going to change. All right? Now the gas is going to take the shape of its container and the volume of its container. The difference is that, and that's up to a point, obviously. If you start putting it under a lot of pressure or sticking it in a vacuum, things start to change. But have you ever been in a house where the windows are open maybe, and somebody opens a door in one side of the house and you feel the other side of the house shake? You ever had that happen? That happens in this house sometimes. Like if somebody can open this door. We were here the other night and the garage door, like you could hear the latch move. It wasn't quite perfectly shut, and somebody moved a door in this house and it caused that door to shift. And it's because the air in this house, although you can't see it, is the exact shape of everything in this house. Like it's got a chunk out here, and it's got little chunks where all the shelves are.
And if of the straw?
Yeah, everything. And if you change the shape of it suddenly, like by opening a door really hard, it affects everything. A good way to see that happening is if you've ever had smoke in your house and opened a window. Nope. So here's a story.
That has happened.
So here's a story. At my church at Easter, we light a fire outside and bring the flame in. Right? So
When did that happen?
they do that every Easter at Vigil.
Yeah,
It's at the nighttime service. So I don't know if you've been to the nighttime service. So anyway, a couple years ago, it was pouring rain on Holy Saturday, pouring rain. So we couldn't really light the little fire right out front of the church in the little roundabout area like we usually do. So we brought it up onto the sidewalk under the little portico and lit it there. Well, when we opened the front doors to the church to bring the flame in, they'd already lit a candle from it. The little, it's a little Weber grill. You know what a Weber is? It's like a little camping grill. They're like this big. They're kind of round. They have a little round lid. We call it the Holy Weber. Well, when they lit the Holy Weber and it was flaming, somebody opened the front doors to our church so we could all process in, and you could see the smoke. And it sucked right in the front, like vestibule area, the lobby area, and everybody was like, "Oh no!" And then my husband, who was trying to be helpful, it's a straight channel from the front door to the back door of the church, and he ran across the narthex to the back door and opened the back door to try and help air things out, and you could watch this channel of smoke go whoosh right across. I mean, it flew through the narthex out the back door because it was going to take the shape of its container, and its container was bigger now, and the flow was that way. And within 2 seconds, the alarm went off, and it started screaming, and the lights were flashing, and then 911 calls on the phone, and we're like, yeah, it's just Easter, sorry. But
What happened? Can I tell a story of when that happened?
yeah, wait, let's wrap up these notes, and then we'll go back to those, okay? All right, so,
I have a question.
yeah.
Are we doing lab, or are we just sitting and watching movies while eating donuts?
No, we're doing a lab.
No.
It's a fun lab, though.
Wait,
But you get donuts, too.
Now
All right, so all of the forces exerted by the individual molecules in a fluid add together to make up the pressure exerted by the fluid. Okay, so look at that one little container with the gas in it again. And I want you to imagine that imagine that it's a pot, okay? And you've put a lid on it. Did you change the volume of the gas?
No.
No, okay. Now you put that pot on a stove and you turn it on. What's going to happen? There's nothing in it. Let's just pretend there's no water in it or anything. It's just gas. what's going to happen? Anybody want to hypothesize?
If you put like a liquid in it, it will vaporize, but since it's already gas.
It's already gas. What's going to happen? Anybody want to guess?
No.
Nope. Okay, so what'll happen is, do you know? What?
The gas will escape the air.
Yeah, it'll try and get out because it's going to expand, and here's why. Look in the little box there. It says all of the forces exerted by the individual molecules in a fluid, be that a gas or a liquid, right, add together to make up the pressure exerted by the fluid. All right, well, if you heat up molecules, they get excited and they start to move around. When they move around, they take up more space. So the pressure is going to increase. And as that pressure increases, it's going to need to get out of that pot. So either the lid's going to come off, or if you've clamped it down, it's going to go kaboom, right? That's basically how bombs work. That's the same concept, right? All right, so let's look at atmospheric pressure. Scrolling down a little bit. All right, anybody want to read those 2 paragraphs at the top with all the blanks filled in? You want to do it? Go ahead, Eleanor.
The pressure
Exerted, you got it.
exerted by the air around us is called air pressure.
Atmospheric pressure, but air pressure is a good one too. Go ahead.
Air has mass, so as gravity acts on the mass, it exerts force over the surfaces on which it presses. This includes the land, the ocean, and you. Pressure will balance fluids, will move from areas of high pressure to areas of low pressures until a balance is reached. Air pressure is also affected by elevation, and likewise air.
Water pressure. Keep going. Water.
Pressure is affected by depth. As elevation increases, air pressure decreases. As depth increases, water pressure increases.
Nice job. All right, so you got some graphics that should be pretty self-explanatory. But if you're this little dude in this warm little jacket and you're standing at the top of the mountain, you've only got. He looks like Kenny. Okay, you only have the number of molecules pressing on you that are between the top of your head and up into the atmosphere. But if you're standing at the bottom, you got more. Your column of molecules is greater, so therefore there's more pressure. If you ever go to a place that's
Earth, you have more air pressure as well.
Where? What? Center of the Earth? Well, yeah, but we don't really get down there.
But like if you were, would you have more pressure?
Yeah. So imagine this. Has anybody ever traveled to Denver or any place that's high elevation? So if you go
elevation?
Up high, like higher up. We're not that high.
We've been going in the spring.
Okay, so if you go place that's really high.
Yeah, I think I went before.
Okay, so if you've gone
to the Grand Canyon.
Okay, so if you go to some place with high pressure, with high elevation, okay, so Denver's a good example because they call it Mile High City. It's a pretty high mountain. If you go, find something like, my husband always has fun with his contact solution. It's like his game every time he comes back. But if it's a bottle and it's closed and you close it nice and tight, the air pressure up there is less because it's way high, right? It's elevation super high. So he screws that little lid on tight, and then when he comes home, the pressure in that bottle is still the same as it was when he was in Denver because he's closed the system, right? But the pressure outside is greater. So when he gets home, what do you think his bottle looks like?
It looks smaller.
It's squished, right? It's all squashed because the air pressure down here is so great that it's crushing that bottle from the outside. So as soon as he unscrews it, it goes, whoosh, and all this air comes sucking in. It's just a game he plays every day. He gets really excited about it. Yeah.
2 more days until Halloween.
I know. All right, so Spider-Man. So that's the first picture.
A good one.
Second, and same thing happens with your ears, by the way. That's why your ears pop when you go up and down.
You're in the Smokies and like,
Yeah.
Are we allowed to have another food candy?
I gotta save them for the other group. I got enough for everybody. So you feel that ears popping. That's pressure in your inner ear trying to equalize between high and low elevation. And then if you look at the pool, if you've ever swum way down to the bottom of a pool, have you ever felt it? Your ears hurt.
Yeah.
Like, okay, I'm going back up. That hurts. Yeah. That's why.
I always thought it because my ears were open. So one time I plugged one of my ears and they both hurt.
Yeah. It doesn't help, does it?
What is wrong with
All that pressure. Yep.
That never happens with me.
And if you look at this little fish in this other picture, that fish is used to.
Never get cold.
That fish,
I know.
that fish is used to having this kind of pressure on him. He's meant to swim down there with a lot of pressure. And when you're in an airplane, they pressurize the cabin for you. Otherwise, it would not be fabulous. Yes.
Would fish have like different bodies if
Yeah.
there's like less pressure in the water?
They would. They're structured to withstand this kind of pressure.
Bottoms that are like near the bottom of the ocean. They look on Earth like they look
Yeah,
like
they
what
do.
you'd imagine like
Okay.
an alien to look like.
All right, girls. All right, so here's the other thing about going up at high pressure that you may want to remember. Athletes that are training for events that involve a lot of cardiovascular work, like cycling or running, those kinds of things, they will train at high elevation. And here's why. Because there's less air pressure, there's actually less air molecules up there pushing on you, there's less oxygen. So they have to train with lower oxygen levels. So when they come back down to sea level or lower elevation in general, their bodies are more efficient because they're used to training with less oxygen. So when they get down lower, it's like, oh, yes, and their bodies are more efficient. And it's actually easier for them to compete. So you may hear about people doing that. All right, so let's look at this next line on the bottom where it says transmitting pressure in fluid. What do these things have in common?
They're all gray.
They're all gray in your picture. Summer would be a lot less fun without these things. All of these awesome gadgets work by taking advantage of fluid pressure laws. One such law is Pascal's principle. All right. Probably the only one y'all may not have seen is the little one in the middle that looks like a box with little rings floating in it. Have you ever seen that before? Yeah, it's water and there's little rings and then there's pegs and you push the buttons and it actually pushes the water and you have to it's endless fun.
Frustrating.
She says frustrating. I think fun.
We have one that is like trying to shoot the rings in like little net.
That's
like,
it.
I know exactly how water gun works.
Okay, well, hang on, I'll come back to it. Pascal's principle states when a force is applied to a confined fluid, an increase in pressure is transmitted equally to all parts of the fluid. If a fluid is not fully contained, increasing pressure on the fluid creates a what? What do we call
Big
it?
mess.
No.
Force pump.
A force pump, which move fluid from one place to another. Okay, a force pump. Now it gets interesting. This gets fun. So we have hydraulic systems. This is the next page, all right? Hydraulic systems are designed to take advantage of Pascal's principle. All right, so look at that graphic there with the car. The one that's on the left, the one that's actually like a diagram, all right? So it says hydraulic system, I don't know, a goofy one. Hydraulic system multiplies force by applying the force to a small surface area. The increase in pressure is then transmitted to another part of the confined fluid, which pushes on a larger surface area. So, y'all looking at this one?
Well,
So we're on, what's the page?
my
5.
only questions were on the back
Were
of
they?
the other page.
Oh, okay. This should be page 5.
I can go get it back.
No, it's okay. It's okay. We'll look at it. We can do it later. I think that's one of the ones that I messed up, and there was supposed to be a blank. There was a blank on my copy, but not.
I had 2 pages.
Yeah, I inserted one, I think, because we had issue with it. All right. So if you look at this diagram, so let me show you. Will you eject? No, you won't eject. It's gonna be like that. Oh, you will. Okay. So this one right here is what we're looking at. All right. So what happens here is there's like a little button, all right? And when that button is pushed, it pushes down on this piston that pushes down on this fluid. Now, usually in these kind of systems, it's like an oil, all right, or some other kind of fluid. This is also how brakes work. It's how lifts work on, like this one, the car lift, but it's also how a lot of other jacks work. It's how you ever seen those dump trucks? They have those big pistons that lift the top so that everything slides out the back. Yeah. So when he pushes here, you girls good? So yeah, okay. Pedro's cousin's car. There you go. So when you push here, it goes down, goes up, and then the force is greater here because it's been multiplied. The force transmitted and it was multiplied, and then it's going to be able to lift an entire car. Now, cars are not light, right? But your mom or dad, when they're driving, can press that one little brake pedal and stop the whole car. That's how. That tiny little brake pedal has a line of fluid And that goes all the way to the brake system, huh?
Trains brakes are
I have no idea how trains brakes work.
trains brakes are like
They're probably all
oh,
different.
yeah, the lever. Yeah, and then when you
It's
pull
a
it,
lever.
it has these-
Yeah, but that's old trains. That's old
big
trains.
pieces of metal with rubber on the end, and then it like goes.
Yeah, I don't know how new trains work though. All right, so this right here, what's this? What's this right here? Y'all know?
I can't see it. This is starfish.
Mm-hmm.
Oh, it's starfish.
Sea star. So this is the inside. It's called a water vascular system. So these kind of creatures are called echinoderms, okay? Sea stars, urchins,
No.
those kinds of things.
Patrick.
Shh, Patrick. Shh, shh, shh.
Jay.
So anyway, they have this wonderful little thing here, okay? And they pull water in through it, and they keep water all inside their bodies. And then they use that water. They have little muscles in their bodies that like squeeze and release all these little systems within their body that basically use, well, no, they use the water to move. Like their muscles work on this system. Well, that's kind of where their digestive system lives, is in the middle. But they move around using water as their primary, it's kind of like, well, I don't know how to describe it. Their primary what? That's their mechanism. I mean, we have muscles and bones. They don't have any bones. So that's how they make themselves move around, is using water. They have a force pump inside their body, which is pretty darn cool. Pretty darn cool. All right, so in your questions, there was one about the amount of water pressure your body experiences while swimming. What's it affected by? The choices you had were your body fat and buoyancy, the volume of water in the pool, the area of the pool, or how deep you are underwater.
How deep you are.
I love it.
Under the water. How deep you are.
How deep you are, right? Very good. The amount of pressure on your body isn't gonna change. Okay. Well, it's gonna be how. That's why I was going over this one. It's gonna be how deep you are. How deep you are.
Unless the area of the pool you're in
Yeah.
is the deep area of the pool.
No, how deep you are. Because that's going to, so when you're underwater, you have to remember that the pressure you feel isn't just the water, it's the air and the water. Everything on you at one time.
That's why for divers, like the big professional ones,
Mm-hmm.
when they have the super high up diving boards, at the bottom of the pools there is like a pipe and it pushes air up towards it to cushion the landing.
Yep. Okay, so.
Have everyone seen what happens when you blow air on sand at the right area? It turns into like a liquid.
Yeah.
It moves around.
There's something that happens with soil when it's wet enough that there's liquid in between all the solid pieces, and it's called liquefaction, and it's what can cause landslides. When we were in Ireland, we went to this place called Cliffs of Moher. Has anybody ever seen The Princess Bride? Please say you have.
I have.
Okay.
The
The Cliffs of Insanity are the Cliffs of Moher. That's where it was filmed. They're huge. It's ridiculous. But they have, careful, they have all these little signs that say, don't stand on the edge of the cliff. The edge of the cliff has been compromised. Somebody died there in October. It wasn't that long ago, like beginning of October, 2 weeks before we got there. And basically, because people keep walking over to the edge, it compromises the edge of the cliff. Sooner or later, it's going to go, right? That's just physics. Sooner or later, it's going to go. But I stood and watched these two, for lack of a better word, really dumb Americans who were tourists, and they were standing there at a low area on top of the cliff that was filled with standing water. And it's not raining right now. So if there's standing water, that should tell you that soil is super saturated. It cannot hold any more water or it would have absorbed it. So it's standing water, and these two guys are standing up there, and the one guy's got a cigarette hanging out of his mouth, and he's trying to tell his friend. I mean, it was like, this is why people don't like us sometimes. But I mean, he was trying to get his friend to back up. Well, basically, he's trying to get his friend to back up as close to the edge of the cliff as he could get to get a picture. And his friend was walking backwards, trusting him. And I'm like, oh, and he actually stepped down. It was about that much lower than the rest of the grass, and it was probably that deep. His feet were probably that far from the edge of the cliff, standing in an area full of standing water. And I'm like, I am getting my phone out because this guy's insurance company is going to want to know how he died. And he took us all off this cliff. I filmed the whole thing, but he didn't fall. But I mean, I was praying, please God, to let this man fall in front of me.
One time we went to the Grand
Someone
Canyon.
get a rock and throw it
Go ahead. Lily was talking. Go ahead.
One time we went to the Grand Canyon, and then as soon as we left, somebody died.
Oh, yeah.
As soon as we left, like
Mhm.
we turned on the news and it said somebody had died at the Grand Canyon, and we literally just left. It was like an hour later.
Yeah.
So we just left, and we were so like thankful that we weren't the ones who were there, because we were sitting on the edge of it, one of it. So my mom,
Scary.
so my dad could take a picture. My mom was going crazy.
Yeah.
Because she thought we were gonna fall.
I'm trying to find that video
Having a
real
seizure.
quick.
That
On
was
the
like
4K
me.
version.
I was like, I'm not getting too close to that. I don't want to die as a child.
There you go. Yeah. This, people are crazy.
I bet there was other people looking at those two guys like, and I bet they were Americans
Where'd
like,
it go?
this is why Americans should never come here.
Trying to find this.
Has anyone seen Corpse Bride?
Another one bites the dust.
All right. So
Another one bites the dust.
we've got.
Another one bites the dust. Another one bites the dust.
Y'all, hold on. We've got time real quick to watch those couple of those videos. There are only 2, and I'd love to show them to you. So, no, the vacation videos. I'm trying to find the first one. They're on. The links are going to be easiest to find, I think, if I just look at my YouTube. I mean, my Facebook, because he tagged me on them. Where'd he go? I saw the first one already. Okay, here we go. Let me take this over to YouTube here. So this is the place on the Isle of Mull. I'm going to back up so you can see it better. Turn the volume all the way up. So Jason chose this music that
Is this on YouTube?
yeah. Jason chose this music that is from, it's some Scottish song, but it's about the island where we were. So hopefully it won't be laggy or anything. That is not mine.
Being assessed in a sailing with sailing
What is that? Right.
We phoned Calmac from Invergary.
I don't know what that was.
A Bugatti.
Bugatti.
Here we go. All right. Let me make it bigger here. All right. It's really cool. Yeah. Yeah. This is. So this is. We had to take a ferry to get to this place because it's an island, and then we had to take a second ferry. This is just his camera, his phone camera. But he gets his drone out, and it's pretty cool. It is a dramatic song, but it's about this beautiful island. I loved her. They were everywhere, those cows. They were everywhere. There we go. There's the drone footage. So look. A toy. This is the house we stayed in, right? Right, that one right there. That's where we stayed in, that little white house. Okay, so now check out the rock formations around this, though. They're really cool. Like, you'll see the vertical ones. Yeah. No, he did not get pictures of your dirty drawings on the beach. Drew dirty stuff on the beach in the sand, but we didn't film it. Well, he did film it, but he didn't put it in the video. He won't share.
I could hear.
Look at the rocks. Do you see what direction they're going? See them going vertically? Weird, isn't it? It's gorgeous. Are you? True. See, look at the vertical rocks here. Do you see them? Isn't that interesting? We did climb up here, and it was pretty cool. Sheep everywhere. Sheep on top of the little island. Do you know how they get to the island? You can tell the tide comes in now. Yeah, go to the roof. Sheep on the mountain. See the vertical rocks though? They clearly don't belong like that, right? Something made them that way.
Beautiful. Maybe someone just said
No, they fell. And these are everywhere. They're my favorite. That's an abandoned. It's an abandoned church, and there's no roof or walls on it. So they put stones inside, and Drew's right there looking in a box. In that box was a very rare type of stone. It's a flat table stone, and it had been damaged, so they built a box around it to keep it safe. No, it was made of slate. Slate. Anyway, it was beautiful. I mean, it's just, the place was beautiful. It was rare, so they covered it because it had value. So I'll show you the list scanner one. That's the end of this one, pretty much. He was not behaving himself. Mm-mm.
What's this YouTube channel called?
He was not being good. Okay, here's the other one.
70 people that have my same name, so it's
All right, so check this one out. This is the last place, and this is mostly just beach pictures, but it's really cool. There we go. When Drew said there wasn't sand, it wasn't like a normal beach, this is what he meant.
But it looks like there's sand.
No, that's all water.
That was the most beautiful place I've ever been.
It was really cool, yeah.
Oh yeah, I'm jumping across there. What did you?
He's not gonna share. There's Drew running around. No, we're not gonna ask because he's not gonna share. This is Irish music, so it's in Irish. They're speaking Irish language. Yeah. I think, is it this cliff? Yeah, I was afraid it was that one. Yeah. Cole's just kicking his feet. Drew, stop yelling. See how they're all these big, they're all these flats, rock flats, and they have like, they call them like limestone carpets and things, and then there are basalt flats, and it's really beautiful. Oh yeah, Jack? Northern Ireland is. Ireland is not. Because they, no, totally different. Ireland is an independent country. Yeah, we see you.
Well, at least you said it. It's North Ireland.
Isn't it cool? It's great footage. This is our little house right here. We stayed right there on the water. It was so cool. It was beautiful inside too. Open. There you are again, Drew. These are always good shots. It's a good shot. So this was real quick though, hang on, Eleanor, real quick. This right here is sunset over the Atlantic, which none of us had ever seen before. You have to be on the other side to see that, right? So that was pretty cool to see a sunset over the Atlantic. I've seen sunrises, but never sunset. All right, so we're good. It's time for a lab. Woohoo.
Are you okay? Yeah, I just got like a little bleeding knee.
I don't ask if she's okay.
Have you ever had yourself at tonight? Yes, I have actually.
All right, y'all get your lab out. Put your name on it. Staple it.
I was 2 years old and I was very stupid. I was trying to cut an apple open, and I thought it would be a good idea for me to cut an apple
literally would fall on holding it and then have the knife and then go like that. So I went.
That's why you're smart money class.
And I got it like that deep. It wasn't very bad, but I was like,
What?
we're doing 12.